Welcome. This is going to be a short video on how to convert from name to formula for ionic compounds. There are three main types of problems. The pink problem, our first one we're going to work here, is for atoms that become ions of a known charge or a fixed charge. So if you'll notice, the first word here is potassium. Potassium is element number 19 in your periodic table. It has a chemical symbol of K. It is an alkali metal, meaning it will always assume a charge of +1. Then we have the word sulfide. It does end in IDE. IDE is the suffix that's used to indicate a monatomic anion, or a single atom of negative charge. So sulfide is going to be S2- because the sulfur atom has 6 valence electrons and gains 2 to get its octet. So now you'll notice I have 2 ions of known charge. Now there's a 1 above here. So what you're going to do is use the crisscross method. You're going to take the 1 and the 2 and you're going to crisscross them across the ions. What this does is it artificially calculates the least common multiple for you. So your chemical formula will have no net charge. So this is the correct formula for potassium sulfide. Our next sample problem is over here in blue. In the blue box, notice it says tin 2. Why the 2? Well, if you look on your periodic table, tin is element number 50. It has a variable charge. So the name must provide the charge. By writing tin 2, you know it's tin 2+. Phosphate is a polyatomic ion you had to memorize as PO4 3-. Once we get to this point, you will of course use the same crisscross method, where we're going to take the 2, we're going to take the 3, and we're going to push them across like this. Now this is interesting because once we've done this, we realize now that of the tins, I want to have 3 of them. The phosphates, I want to have 2 phosphates. So I must put this in parentheses, and now I have 3 tins and 2 phosphates. So this is the correct formula for tin 2-phosphate. My last example problem here is barium oxide. Now barium oxide is an interesting one because the barium atom is an alkali earth metal, number 56 in your periodic table. All alkali earth metals have a charge of 2+. Oxide is on the right hand side of the table. It's a non-metal, has 6 valence electrons, so its charge will be -2. When I use the crisscross method, like we've seen illustrated in the last 2 examples, what happens is this 2 and this 2 get pushed across, as you would expect. Well, the net result, however, is I end up with a chemical formula saying Ba2O2. When you write ionic formulas, they need to be in their most reduced form, which means this needs to be reduced into BaO. This is a reduced pattern. Hope you enjoyed this short video.